To summarize, most of electrostatics is to understand the electrical behavior of conductors and dielectrics. When a charge is brought nearby, starting with a neutral conductor slash insulator, it behaves electrically as follows. If it's a conductor, conductors use induction as a charge transfer process. On the other hand, insulators, dielectrics, use polarization as a charge transfer process. Interestingly enough, conductors and insulators are effectively the mere opposites that is electrically of each other. Now let's explore these differences. So the first thing that I'm going to look at is I'm going to look at conductors and induction. So what you want to think about is that if the charges inside a conductor moves around because of an external charge. I mean, isn't that what conductors do? Conductors allow charge to move. So the charges inside a conductor, they're going to move around because there's an external charge. There will be a charge separation. Even if the conductor is neutral. The conductor's not charged. All we're doing here is that we're causing a charge separation. That's the main point right there. This movement of charge is called induced charge. And is the main characteristic of conductors. So I'm going to go through a conceptual example, but that's what we mean by induction. When there's charge separation, because conductors allow charge to move. That's the opposite of what inductors do. So let's go through a process here. So the first thing that I have to do is I have to start with a neutrally charged rod. So here's my conceptual example. So we start with a negatively charged rod. So let's say that here's my rod. And on this rod, we know that this rod is charged. So this is a charged rod. That means that these electrons have been transferred onto it. And so what I'm seeing here is that now I have numerous electric charges. And we'll say that it's negatively charged. I could have made it positively charged. So now we need to talk about our conductor here. So what I need here is that I need an isolated neutral conductor. So in this case, I'm going to say that I have a base, and this base here is set up as insulators. So let's be careful here. So here's these guys that I'm looking at right here. Now it's important to realize that this right here and this, they are insulators. And this is what we mean by an isolated neutral conducting sphere. In this case, it's a sphere, but it's really a conductor only. And then I'm going to color this gray here because it's a metal, right? So this guy is a neutral conductor. Now, what I have here is that I have organization of charges. So what I'm going to do here is that I imagine that I have nuclei, and these are my nuclear ions right here. And what we're finding here is that with each each atom, I'm going to associate red electrons. Now, what I'm going to do here is that now I'm going to bring the rod close to but not touching. So now what actually happens here? So if I come in here and I start copying and transferring, so here's my charged rod. Now I need this guy here, which I will modify. So here's where this guy's at. And so I'm bringing this guy really close to this, but no contact. So now what happens? What happens here is that the positive nuclear ions do not move, right? The only thing that moves are the electrons. So what I'm doing here is that I'm erasing the electrons because now what they have done is that they have moved as far away as possible. So as a consequence, here's what we're seeing here. What I'm seeing here is that on this side right here, I have more electrons, which then tells me that this is negatively charged. So this is now more negative than positive. On this side right here, right in here, I have less electrons. So then that tells me that this is now positively charged. So now this is what we mean by induced. But this picture is not what's commonly drawn here. Okay, so now what I'm going to do here is that I'm going to now I will draw an effective picture of the induced charges on the isolated conductor. So if I redraw this thing, that's not the way we typically draw it, the way I just showed you here. So if I now focus only on the sphere, so what is it that I see here? What we do here is that we ignore all the distribution of charges that we just saw. And what we effectively do here is that we say that on this side, I have developed a positive charge. On this side over here, I have developed a negative charge. So this is positive, and this is negative. So now the language is like this. I'm actually going to move this down just a tiny bit. I need a little bit more space. This is what we say is that this is induced negatively. This guy over here is induced positively. And the crazy thing is that right inside of here, this is neutral. So it's neutral inside. As we will find out later that the charges are all on the surface of the conductor, not on the inside. That is an induced sphere right there. But that's not charging by induction. Now what we want to do is that to charge the conductor, which is defined as charging by induction, requires a second, what I call a second grounding conductor. That removes excess electrons. So again, let's start off with our picture here. So what I'm going to do is that I imagine that I still have my charged rod. Okay, I have my charged rod. And here she is right here. And then I need my sphere. And then this is my sphere right here. So I've now induced the charge here. Oops, I thought I copied this, but apparently I didn't. So now here's my sphere again. So it's important here that the charged rod must be very close to the sphere. Okay, it has to be close to the sphere. Now, what happens here is that if this is really close to the sphere, it causes induced charges. It causes a positive and a negative induced charge. So now what happens is that we come in with an conductor, a grounding conductor. And typically when we draw a grounding conductor, it's typically a sphere and it's connected to some type of ground here. So again, this right here gives, and so what this does here is that this grounding conductor allows charge to move off the isolated sphere. So now what I'm going to do here is that I'm going to bring this over and I'm going to make contact. As soon as I make contact, it turns out that now I have a transfer of charge. So in other words, I'm now removing charge. So as I remove charge, what actually is happening here? What I do next is that I do the following thing. I take my charged rod and now I separate it. So I keep it far away. And if I look at this guy, the first thing that happens is that the grounding conductor has now given a path for those red electrons here. So if I come over here and I copy this, so now I remove this out here, and what has happened here is that these charges now are now given a path where they are now leaving. So that means that they're moving down to the ground, but these are the negative charges. As a consequence, these positive the charges now, what they do here is that they rearrange. And since I have less negative charge, I develop a positive charge here. So the charges rearrange themselves so that now I have what is called a positively charged sphere. So I'm going to show you a video here in a moment, but I want to look at what's called the pith ball and charged rod. So this is going to be a physical example, which I will follow with the video. And here's what we find. This physical example is called the pith ball and charged rod. So the first thing that I have is that I have this thing. So what I have here is that I have hanging here a string with a tiny conducting sphere. So what you're seeing here is that this guy right here is a conducting sphere. And it's important that it's neutral. So the way you neutralize it is that you give a path. So if you touch it with your hand acts like this grounding conductor. So now the next thing that you're seeing here is that I'm going to bring a charged rod nearby. So what you're seeing here is that now here is the pith ball. And what you're finding here is that right here, this is a negatively charged rod. So I'm going to say that this here is a negatively charged rod. So what happens here? So if I was to look at this conductor, what I'm seeing here is that I have my conductor, and the first thing that happens is that I induce charge. So what do? Very similar to up here, I push all the negative charges away. So in other words, in this situation, I'm going to say that I'm pushing all my negative charges away, and as a consequence, I produce positive charges. So now what you're seeing here is that I have what? This is an induced conductor. Now, because there's separation of charge, you're seeing that between these two, the rod and the sphere and the hanging conductor here, that now there's an attraction between them because it's positive and negative. So now there is a conductor insulator interaction. And what you're seeing here is that now when I look at this guy again, you're seeing that here it was being attracted, here it's being repulsed. So what happens here is that when I look at this thing, some of the charge here has now been deposited. So there's missing charge now. So right in here, you're seeing that there is missing charge. And what happens here is that the excess amount of charge from the um, insulator gets transferred to the sphere. So now if I look at this thing, you can see that this guy has some motion. It's moving in that direction. And the reason why it's moving here is because I have a negatively charged sphere. So as a consequence, I now have repulsion. So now what I want to do is that I want to show you this live here. So let's look at this video. And if you look at the links, I labeled this as pith ball and charged rod. So this is a YouTube video, and I think it's quite good. So let's go look at that video. And here it is. So the first thing that you're seeing here is that note that the person is touching the pith ball with his hand. This is important because it neutralizes the pith ball. So here we go. You could see the attraction right there. That's because you've induced the sphere. Now there's contact, and you could see that they now have the same charge, and there's now repulsion. And that's because they have the same charge.